Okay, so let's figure out the ADA grade. Now the problem with the ADA grade is, if you guys want to come around here to see this, that's totally awesome. I'm going to put it, of course. The problem with measuring the grade of a ramp is what?
Using the stairs to measure.
I couldn't do what you guys did. You guys had stairs. So essentially a stair is nice because you see a rise and you see a run. What do I see with an ADA ramp?
It's like a road.
Continuous.
Exactly. What's that great word? What's the part of a triangle that you're a hypotenuse? Remember that crazy word from last time? Yeah. So what you guys actually get on an ADA ramp is a hypotenuse. So this is the ramp right here. That's the trick. In other words, I can't get the run. That's hidden. Is it changing? It's kind of cool. This is hidden, although we can get it. We can get it using mathematics, which we will get. So what I was able to get using a 200-foot tape was the length of that hypotenuse. And the length of that hypotenuse was, hang on. Gotta look at it again. I took pictures. And then sent them to you, which you'll see eventually. It was, that's my USB, I don't need that, I need this. 25 feet 1 inch. That is the length. That's terrible. Might get darker. That's not much better. 25 feet 1 inch. That's the ramp. Is that even visible at all? Okay, I'll just say it like 5 times.
All right.
25 feet 1 inch. Why did I use my other markers? Maybe I just used the normal ones. Let's see if this works. Boy Scout, be prepared. Yeah, it's much better, huh? Now, there is one assumption I made about the ramp. I made this assumption. I made the assumption that even though I couldn't see the rise nor the run, that the rise and the run are perpendicular under it. I think that's fair. I mean, if I drop a rock on Earth, it's going to head straight towards the center of the Earth, which is a plumb line to perpendicular. So I think we're okay assuming that. So I can't get this. So I have to be able to get this. So the question is, how do I get that? That's where that instrument came in handy. I set up this guy, and then I shot the elevation out across. And the drop from where that guy visibly was out, so it was up here, the transit was up here. Transit, I don't know how to draw that. Let's draw a rectangle with it's kind of like that camera over there. Okay, this shot, and thankfully my friend Jordan was walking by at the time, and he held the stick for me the other side. This drop right here was 7 feet. 7 feet and oh crud. 7 feet, 0.5 inches. 7 feet, 0.5 inches. Now, the kicker was, and it moved before I got a chance to measure this accurately, I'd have to also know how high the transit was off the ramp. Think about, right, because obviously the ramp doesn't go 7 feet, 0.5 inches. The ramp itself goes whatever the difference is between that. The problem was I kicked it as I was moving it, so I didn't get a chance. It was about here-ish. So we're gonna have to get unfortunately, all this great precision is gonna be thrown out the window right now. But it's okay, the mathematics behind it is fine. What do you want to call that? You got a tape on you?
4 feet tall.
4 feet, call it 4 feet, let's just make up a number. It doesn't, the exactness is gonna be lost because of the fact I ruined it by kicking it. So let's just call this 4 feet from here to here, which means we now have our rise, don't we? It's 3 feet and a half inch, which we might as well just call 3 feet because the half inch is meaningless now because I kicked the damn stand. So let's just call this 3 feet just for grins, because we might as well make the math easy, right? You know, while we're at it, let's call this 25 feet because why the hell not? Let's just make the math easy. The math is the important part. I mean, if I wanted precision, I wouldn't have kicked the damn stand. So as long as you understand the math, you can do this whatever time you need to. Good so far? Is that all visible?
Yeah, you can
Ish?
see it better in the.
It's
yeah.
getting better, okay, good. I'll keep using the darker colors. So now the question is, what's the grade? Now there is an incorrect way we can do this. We can ignore the fact, go ahead, Katie, what were you gonna say? Go ahead, no, what's the incorrect way? Go ahead.
Times it.
Well, that would be correct, yeah.
Yeah.
But there's an incorrect, let me rephrase my word incorrect. There's an incorrect way we can do it that can almost be passed off as correct. And that's to use the hypotenuse as the run. Now that won't be right, because the hypotenuse is not the run. The hypotenuse is water than the run. Water. It's longer. So if I use the hypotenuse, the grade's going to be 2. This is going to be a great question, actually. So the hypotenuse is longer than the run, yes? So if I calculate the grade with the hypotenuse, how is that grade going to compare if I did it correctly?
Oh, it's not gonna be steep.
It's going to be shallower, isn't it? It has to be. If you don't see why, let's do it both ways. Let's do it both ways, yeah? Okay, I'm going to need you guys with technology to help me out to get any semblance of decimal accuracy here. Suppose we do the grade. Can I write over on this side? Will it be visible in the camera-ish?
Yeah.
Okay, good. Let's do the grade the wrong way. Hey,
Hey.
nice.
Chicken scrubs?
Let's do the grade. Giant squirrels. Let's do the grade. Is that ish visible?
Yeah.
It's getting there. Okay, I'll keep verbalizing things so you have it too. The wrong way would be to rise over the hypotenuse. But that's not what grade is. Grade is rise over run. But the wrong way would be forget the run, call the hypotenuse because the hypotenuse is close enough to the rise anyway. Or excuse me, close enough to the run. Thank you, Frankie. The run anyway. And sometimes, and we're going to study this in this class as we get deeper into grade, it's okay to do that. It's okay to just say, you know what, the run is too hard to get, as it often is. Just use the hypotenuse, call it the run, and call it good. Well, what would that be in this case? Well, we got the numbers we need, right? It's about 3 feet over 25 feet, which as a decimal is like 3/8 is 12. Is that 11.5%? What do you guys get? Can we crunch that for me real quick? Thank you, that'd be awesome. I'm going to say 11.5%. Smaller than that. 0.12! Oh, you like me now. 0.12, 12%. 12% grade. 12% grade. So roughly a 1/8. If you want to round it off to the nearest fraction, for every foot, or for every 8 feet this way, it's 1 foot this way. Which I think makes perfect sense if you think about this. It runs essentially 25 for every 3 that it rises, but that's kind of wrong, yeah? Because it doesn't run 25, it hypotenuses 25. That's not the run. So could we get the run, though? Can we get the run from this image?
Use a squared plus b squared equals.
That's the one! Thank you, Michael. From the Dr. Pepper bottle comes the answer. Yes, we use Pythagoras. We use Pythagoras. Let's use a different color. Right. Yeah, so we can figure this out because we know that this squared, rise squared plus run squared equals hypotenuse squared. We know that, right? So rise squared plus run squared equals hypotenuse squared. So now I'm going to solve this equation in one step. It might piss some of you off, and that's okay. The first project that isn't due till next week has you solving this exact same equation, actually the one that Mike quoted, a squared plus b squared equals c squared. I don't use the big words like this. But I'm going to solve this in one step. If you don't like it, then you can go check the project and you'll see why it works. I promise you. I'm not trying to put it off on you. I'm just saying it's one of those things you probably learned in 95 and then have since forgotten, and it's okay. But it's worth going back and looking at again. The run, therefore, is going to be equal to the square root of the hypotenuse squared minus the rise squared. If you were to solve that equation for run, that's what it would be. The square root of that difference of those two squared quantities. If that upsets you, and it might, I apologize, that first project has you solving for either A or B, I forget which one it is. I tend to not use the A and the B and the C. I tend to use rise and run and hypotenuse only because that way we keep track of who is what. But in case you need practice and see how to do it, then you can get it that way. Fair enough? All right. But this is good for us because now we can figure out what our run has to be, yes? The run, which is right here, I don't like that. Let's go back to blue. Our run, or black. Black and blue, they get a bruise. That's good. Ooh, starting to run out of ink now. Please. I have 3 R's on the board, that's excellent. So your run is going to be that, the square root of the hypotenuse squared. So that's the square root of 25 squared minus 3 squared. That, I think, is 625. I think that's 9. 25 minus 9, 60. Is it going to be 616? Did I do that right?
612.
612. Thank you. Square root of 612. What is the square root of 612? I know it's less than 25.
24.74.
But not much! 24.7. So remember what we said? We said the hypotenuse is the longest side of any triangle. That doesn't mean that it's a whole lot longer. It just needs to be a little bit longer. I didn't draw this thing very well to scale, did I?
616.
Oh, it's 616. I did it right the first time, didn't I? So what's the square root of 616? Is it 24.7? Close enough to that to call it 24.7-ish. 24.7 is fine. It's close enough, I'm sure. But the idea is this. I did not draw this thing to scale, remember? If this is 25 feet and this is 3, there's 3, there's 6, there's 9, that's about 12. I made this thing look about twice as steep as it actually is. That's why the math is important to back up the image with, so you know with the numbers you're actually cranking are correct or not. So, if we did the grade the correct way, this is the grade the wrong way. Can I write, how about over here? Maybe swing the camera so we can still see it?
Yeah, you can see it.
Good. Let's do the grade the right way. See a lawsuit happening. The grade the correct way would actually be the rise over the run, yeah? It'd be the rise over run, which would be the same rise of 3 feet, but now it's over the run of 24.7. How does that affect the overall grade? This was, we said, this is the wrong way, we said it was about 12%. What is it the right way?
Less.
Right.
The grade is going to be less.
It's a little steeper, isn't it? It's a smidge steeper. But my actually, this is a good point, Amber. Thank you, thank you. This fraction is 3 over 25. This fraction is 3 over 24.7. So what you're looking at is you're looking at this number is smaller than 25. But the denominator of the fraction is smaller. What does that do to the fraction? It makes the fraction actually larger. Think about this. Think about the fraction 1/3. Okay, think about this. The fraction 1/3. Now think about the fraction 1/2. Which one is bigger? 1/2. Because the denominator is smaller. So this one has to be larger numerically than that one over there. But my question is, does it round to anything different than 12%?
No.
No, it's almost arguably the same 12% grade because it's not that much different. And my point by saying this is, yeah, that is the incorrect way of calculating the grade. But if you need to get the grades that way, very often you can because you get pretty close to the right answer. On your first exam, you'll do in a couple weeks to turn in a couple weeks. I took a elevation shot using that GPS tracker we're talking about in class of a road ride that I do. And it gives me hypotenuses and rises. It doesn't give me runs. And the reason it gives me hypotenuses and rises is because it's tracking me as I ride on the road. I'm riding on the hypotenuse, if you will, right? Unless I'm going flat. If I'm going flat, I'm riding on the runs. But the roads that I ride on generally don't go perfectly flat. They go up, they go down, they go up, they go down. So you're riding along these hypotenuses. But as you'll find sooner than later, it doesn't really matter if you do it wrong or right, so long as the angles aren't very steep. When the angles start getting really, really, really steep, then you can't do it the wrong way. I was in Utah at the old Olympic Training Center. I guess the Olympics were there back in 2002, right? 2002, I believe the Winter Olympics were in Salt Lake City. And I rode the bobsled. I had to save up for like 3 weeks to pay for it, but it was totally worth it. So I got to experience like the G's of a mile-long bobsled ride. Totally freaking rad. And I was figuring out the grade of it, and I realized it's a huge difference if you do it the right way versus the wrong way, because sections of that track are like dropping out from under you. I mean, you can feel your guts like slopping around. Totally, totally fun. But that's where you don't want to do it the wrong way. You want to do it the right way, otherwise you get a completely deflated version of what the grade should be. But those are extreme cases. You're not driving on roads like that, or you're not walking upstairs like that. Make sense? Yeah, good stuff, good stuff. So that's an introduction to grade-ish. I didn't have you guys do the angles on these, but if we needed to, could we get the angle on this? Absolutely. I would pull it up if we were in class. I'd pull the tangent sheet up. In your homework, I have a link to one. So you can always just go to your homework and hit that link and it pops up a tangent grade. Or a bunch of you guys were Googling it over there. It was fantastic. There's tons of them, right? And they're all the same. And in your homework, I also show you how to use a TI-83, how to actually do the angle directly on the TI. So you don't have to go to an internet connection if you don't want to, although the internet connection is probably easier than learning the TI command. So I think we'll call it a day. What time are we looking at? 41. Rather than getting into the next thing, which is kind of silly to do, let's call it a day here. Let's make a pile of the quizzes somewhere so we all have them. That's fantastic. And for Wednesday, looking forward, I posted 2 quizzes for you guys for Wednesday. One is on grade, stuff we're going right now. One is on, it's a primer quiz, just prerequisite kind of math skills. Do one, both, or neither. They're optional, remember. I also put a second quiz up. Katie, you inspired it, thank you.
Oh, yeah,
you asked about Burma
that's
Road.
great.
Next week, it was awesome. The question was, what is the average grade on Burma Road? Burma Road is a trail, it's actually an old Jeep track at Smith Rock State Park. You ever gone to Smith Rock State Park, and you go to the far end of the parking lot where it loops back around on itself, and you look across the hillside there's a crazy dirt road that winds up the hillside. There's a big switchback and then cut, that's called Burma Road. It used to be called Burma Road, I'm not sure if it still is. It's very steep, especially if anybody ever hiked that road? Ever hiked Burma? Katie, I know you have, I have, I've biked up it. A couple of us have, yeah. I've ridden my bike up it, it's hellish. The question is, what's the grade? Katie, go ahead.
Do you hike you've even hiked up the hill that even goes like to hell, up all the way up, right?
The low part or the upper part?
Well, like when you're standing on Burma, you can actually see more of a hill that keeps
Oh
going.
yeah, we've gone up and over. Yeah, yeah, it's ridiculous. It's ridiculous. But the question is, what's the average grade on it? And rather than just tell Katie the answer, I turned it into a quiz for next week. So it teaches you, because I'm a bastard. Because I'm an absolute bastard. No, you do not have to drive out there to do it. It'll be fun. Maybe you would do. But what I did was I gave you everything you need to know in the quiz. I found a topo map of the park, which was great. That's how you get your rise. You'll learn how to do this in the quiz. And as far as the run, you'll have to use a little bit of scale finding using maps, which is also given to you in the quiz. So you can figure out the average grade of Burma Road based on that. So that's for next week. So I got a couple quizzes for grade. We'll start some new stuff called linear regression in class on when I see you guys again? Wednesday. I'll see you guys again Wednesday. So we'll do that then. So we got to make a little pile. I'd like, since we have some time now, does anybody have their TIs with them? TI-83s? I've written some programs, and I'd rather, it'll link up with 84s as well. If you have your TIs with you right now, let's link you up with the programs I've written. It'll save us time on Wednesday. Okay? And other than that, we are done. So make a pile maybe over here with the quizzes.
Do you have that program elsewhere, like on your site, maybe?
I can put it on the site,
Okay.
but that requires that you have the cord to connect to the computer. If you have that, you're golden. Send me, okay. Well, send me an email and I'll make sure they're postable.
Okay, cool.
He's just got a program.
Every time my battery's done, I lose all my programs that I
Your lithium battery is also dead. I'm by the office, I can set it. There's a fifth battery in your machine. I'm trying to not let that happen. And it sounds like your lithium battery died. That's probably not. So let me, could one of you guys, Cassie, can you shut down the camera? Thank you so much. Let me grab mine.